So today we're going to continue studying how to design an ER diagram. So in the last class, I think we mainly focused on discussing on how to model a relationship type and also how to specify the constraints of relationship type. So I think in last class we discussed in details about coordinate ratios. So coordinate ratios basically use two numbers to represent a constraint on a relationship type. So the meaning of that number actually indicate the maximum number of relationship instances that an entity can participate in. So then we have three types of coordinate ratios: one-to-one, one-to-many, and many-to-many. Okay. And for many-to-many, we actually use N and M, both N and M representing multiple, more than one. Okay. So we just don't want to use 2N. So we use N and M to try to distinguish the numbers on each side of a relationship type. Okay. I think in the last class we also discussed how to place those numbers, and we have to be careful that the number has to be put in the right location. Otherwise, the semantics of those constraints will have totally different meaning. For example, employee manages department. So the one on the right side of the manages representing the maximum number of these manages relationship instance that an employee can take. So maximum one, so means that an employee can manage at most one department. Okay, then the one on the left side basically describe the maximum number of relationship instance that a department can participate in. So this one really indicates that a department can be managed by at most one employee. So the semantics here basically means that a department can have only one manager or only one employee manage it. And also given an employee, she or he can only manage one department, no more than one department. So for the controls, so the N on the project side actually describe the maximum number of the relationship instance that a department can participate. So N means multiple. That really indicates a department can control multiple projects. So when we're talking about a relationship instance view relates individual entity of the two participating entity type. So a relationship instance for the controls will relate one department with one project. So one and one. So if a department control, for example, 10 different projects, then that department will participate these controls 10 times. So in other words, the department has 10 relationship instances, one for each project it controls. Then the one on the left side describe the maximum number of relationship this controls relationship instance a project can participate. Okay, so one means that a project can be controlled by one department, no more than one department. Okay, so the last one, the employee works on project. Okay, so we have MN, so that indicates this is many-to-many relationship type. So N on the right side indicate that an employee can work on many projects. So an employee can participate more than one relationship instance. This works on relationship instance. So remember that one relationship instance can only relate one entity from an entity type with one entity from another entity type. Okay, so works on relates one employee. So one works on relationship instance only relates one employee with one project. Okay, so if an employee work on like 3 projects, that means that that employee will participate the works on relationship instance 3 times. Okay, one for each project. So that's M means. M also describe the maximum number of relationship instance that a project can participate in. Okay, so M also means many. So that means that a project can be worked on by many employees. Okay, so the location of this NM1 you should be careful. Okay, so we always put, when we put a number, when we describe, for example, a relationship, I mean the maximum number of the relationship instance, an entity type like employee participate, we have to put the number on the other side. Okay, not on the employee side, but on the other side. When we describe the maximum number of the relationship instance for project, we have to put that number on the employee side. Okay, so that's basically, you need to be aware of that. And in the last class, we also discussed the participation constraints. So coordinator ratios describe the maximum number of relationship instances an entity can participate in. Then the participation constraint actually describe the minimum number of relationship instances that an entity can participate in. Okay, so we have partial participation or versus total participation. So that's the only 2 participation constraint, possible constraint. So for the total, we use double line connecting the entity type with the relationship type. Okay, so this total on the department side, the total basically means that the minimum number of the relationship instance a department participate in the manages is 1. So what this 1 really means that every department must participate in this managers relationship so that it can be related to its manager. Okay, so participation of the department is total, represented by the double lines connecting to the department and managers. Then the participation of the employees actually is partial. Why partial? Because given the employees, for example, the employees entity set, the only employees who are a manager then will participate in the manager's relationship. If an employee is not a manager, he or she will not participate in the manager's relationship relationship type. So that's why the minimum number of the relationship instance an employee participate will be 0. So 0 means partial. Okay, I think my understanding, usually I'm thinking why it's called partial, because not all employees will participate in these managers. So that's why the employees participation is partial. So we just keep the single line connecting the employee with managers. For the department, its total participation means that all departments or every department must participate in these managers. So that's a total. Okay, total participation constraint representing by double lines. Okay, here. So let's move on to the controls. So department controls project. So we have already supplied the coordinator ratios. Now we need to specify the participation constraints. So let me bring give me a moment. I need to, bring the company database description. you're able to view it. Let me bring. So the reason when we specify the relationship type in constraints, we have to use data description so that we can infer, infer the the database description to find out what are the constraints. So hard for me to print this one, sorry. Okay. Okay, now I think you're able to view it. Yes, that's pretty much it. Let me see, come on, I need to. Okay, so when we discuss the both catenator ratio constraint and participation, we have to infer the data description to see if we are able to get those information from the data description. If yes, then we can supply the corresponding constraints. If no, then we have to make assumption. Okay, so I think we have assumption already. Some assumption made it already. So for example, we have each project can be controlled by only one department. And that's the one here, okay? Then each project can have multiple employees working on it. So I think we don't have this. Should be the, do we have other one? Yeah. Issue the work zone, I think. Yeah. Each project, exactly. So that's representing this M, okay? And then for the participation constraint, the same thing. So for the department controls project, so what's the participation of the, maybe look at the project. So according to the data description, each department controls a number of projects. So that really indicates our department controls some project. So that's basically, we can use that to determine the participation constraints of the department for the controls relationship type. So since every department controls a number of the project, so that indicates the department participation constraint will be total. Okay, so it's not that. Okay, so that means double line. On the department side means total participation. Then for the project, so it said each project has a name, number, and is located at a single location. It didn't tell us that a project must have a department to control it. Okay, so that's basically, I think, at this moment we have to make assumption in order to determine the project's participation. So I think project can be the total participation or can have the partial participation, really depending on the organization's kind of business rules. So maybe some organization, they can have a project not controlled by any department, maybe controlled by employee. And some organization, maybe every project must be controlled by at least one department. So, I think it's really depending on the cases. But given this sample company database, we do not know which case that company database will be in. So then we cannot just blindly assume one without telling them that this is our assumption, so that we can really go back to the client to validate our assumption. Okay, so for example, if I assume that a project must be controlled by a department, then I'm going to put the double line. But I want to you understand that if you make a different assumption saying that a project might not be controlled by any department, that's fine. But you have to list your assumption in the assumption list, and then you have to make sure that your design is consistent with your assumption. Okay, so I think if you don't have any information, you can make any assumption you want. But the thing that you have to go back to the client to verify your assumption, to make sure that your assumption really meets their kind of business rule. Okay, so for the number 3, I assume that each project must be controlled by one department. Okay, so then I put the double line here. But again, if you make a different assumption, if you think a project not controlled by any department, that's fine. Then you're going to have the single line here. Okay, so it's solely based on your design. Should be solely consistent with your assumption. Okay, so I think maintain your assumption is very nice because you can validate those assumptions. If some assumption does not meet with company's business rules, then you can revise your assumption and then revise your design accordingly. So that's make your design more kind of how do I say excuse me kind of better serve the client. Okay. Okay, go to the next one. Employee works on project. So let's go to the description here. So for the employee, we have something. Can I just make it a little bit larger? I'm just worried. Okay. I think now it should be better. So seeing that each employee has social security number, address, and blah blah. Then each employee works for one department and then may work on several projects. May. So I don't know. This may means that they may work on one or several, or they may work. They have to work on some projects. So then I think for the participation of the employee, we are not really clearly able to infer the participation of the employees for the works on relationship. So that's why I may want to make another assumption. I assume that some employee may not work on any project. Okay. So if that is true, then I believe this line at single means that employees' participation is partial, because only partial employees participate in this work zone, not all of them. Okay. So, but if you make different assumption, then you just draw a double line if you want to make sure that each employee must work on some project. Okay. Then on the project side, so when the data description only says project's name, but does not specify that a project may have some employees working on it. But I think usually you have a project must be worked on by some people, right? Some employees. So, so in this case, although I think this assumption might be redundant, but it's better to put here. Let's have some employee work on. Sorry. I think my this display response time is so slow, so sometimes working on it. Make sure I'm typing right. So then I'm going to put the project double line. So it means that the project's participation is total. Means every project has to participate in this works on relationship so that they relate to at least one employees, right? Okay, good. So that's for the participation constraint. So as of now, we actually study the two constraints to describe a relationship type. So coordinate ratios represented by two numbers and participation constraints represented by single line or double line. So single line indicate partial participation, double line indicate total participation. By total participation, we mean that an entity type or each entity in an entity type must participate in a relationship. Partial basically means that some entities in an entity type will not participate in that relationship type. Okay, so that's called partial. So let's see. So I think this kind of way, so far we kind of discuss both coordinate ratios and participation constraint. So according to their definition, coordinate ratios representing the maximum relationship instance an entity can participate, and participation constraint representing the minimum number of relationship instance an entity can participate. If the minimum number is 0, that's corresponding to the partial participation. If the minimum number is 1, that means every entity must participate in that relationship type. Then the participation will be total. Okay, so that's kind of the way. So this kind of an overview of the notation for the ER diagrams. So recall that for the ER diagrams, we need to, I think the 3 important things we need to capture: the entity types that are representing what type of data we need to store in the database. Second one is the relationship type. So relationship type really describe a relationship between 2 entity types. Okay. And then for each entity type, we also need to specify the attributes. So attributes describe the property of an entity type. Then for the relationship types, we also need to specify the constraints. So as of now, we study the 2 sets of constraints used to describe a relationship type: coordinate ratios and participation constraints. So then, regarding to the ER notation, we use rectangular box to represent entity types, then a double rectangle box representing weak entity type. Okay, so usually when you design, you always start each entity type as the regular or the strong entity type. Then after you finish your design, you may need to do the remove the redundant attributes. Then after removing redundant attributes, you may realize that some entity type no longer have a primary key. So at that moment, you can refine that entity type into a weak entity type. Okay, then for the attributes, we need to distinguish either a single or simple attributes, use a single oval, or multi-valued attributes, we use double ovals, or composite attribute means that an attribute has several components. So we always connecting an attribute directly to the entity type. But for the components of a composite attribute, they only connect to their corresponding attribute. Okay. Then for the key, we need to underline the primary key for each entity type. Okay. So this shows how we represent an entity type. Okay. So in this case, we have 5 single attributes and we have 1 composite attribute called the name. So we underline the primary key as SSN. And for the relationship type, we need to specify coordinate ratios and participation constraints. Yes. And the one thing I think when we describe the weak entity type, so we know that weak entity type will need to be represented in a double rectangle box. Then we also have a double diamonds. So these double diamonds specify can specify a specific relationship type called identifying relationship type. So identifying relationship type simply identifies the owner entity type of a weak entity type. So in this notation, we know that the owner entity type of dependent is employee. So I think this kind of in this case, we consider that the dependent's existence in the database has to rely on its associated employee. So the reason we think that is because if the associated employee left the company, then the dependence information will also be removed from the database because there's no meaning to maintain the dependent information if the employee, left the company. Okay, so and when we refine it, we have set of attributes really indicate, okay, they will not be able to uniquely identify dependent. But I think in practice, okay, so let's go back to it's really depending on the user's needs. So for example, here, come on. So for example, here, when we record dependent information, we only record their name, sex, birth date, relationship, and we also employee name. Okay. So I think it's maybe a common practice that in the real world database, we assign a kind of unique ID for each for each entity or each record in the table. So usually we call that surrogate key. So more like a row index. Okay, so if the company requires that we assign a unique ID for each dependent, then for that situation, then dependent still considered as a strong anti-type. Why? Because ID used to uniquely identify each dependent. Okay, so in that case, dependent will be considered as a strong anti-type. Although dependents still need to depend kind of rely on an employee to be to exist in a database. But in the ER design, that dependent will be considered as the strong anti-type. So for this example, because according to the data description, when we record the dependents, we actually keep track of their name, sex, birthday, relationship to the employee. Okay, and also I think in this case we use e-name as or employee information as attribute to the dependent. The data description does not saying that we need to create a unique ID for each dependent. So according to the data description, when we remove this e-name, then dependent becomes to a weak anti-type. Okay, so here I want to let you know that your database might be not the same depending on the user's requirement and their implementation consideration. Okay, so your design should be fully following the data description truthfully. You do not need to add any extra information to the database or to the data description, but you should try to capture all the information stated in the data description. Okay, so then if you make some assumption, you have to really list your assumption. That's very important. Okay, good. So I think so on we finished the discussing of relationship constraints. I want to introduce one more. That's about minimum maximum notation. So that's similar to so this is called the minimum maximum notation. So recall that coordinate ratios and participation constraints simply representing a maximum number of relationship instances and a minimum number of a relationship instance an entity can take. So another notation is called the minimum maximum. So that's very identical to the coordinate ratios and participation constraints. But here we just use numbers to representing. So for example, for the employee, we use a pair of number. The 0 means minimum number of the relationship instance that employee participate in these managers. And the 1 indicates the maximum number of the relationship instance an employee can participate in the managers. So what does that mean? So 0 means that partial. If the minimum number of instances is 0, that means some employees may participate in the managers, some may not. Okay, the maximum 1 basically means that an employee can participate only once in these managers. So that will be interpreted as an employee can manage only one department. Okay? So the pair 0, 1 in this case, in this minimum maximum notation, will be used to describe the employee's participation property. Then on the department side, we also have a pair 1, 1. So 1, 1 also indicate the minimum number of relationship instance for department participate in is 1, and the maximum relationship instance a department participate is also 1. So what does that mean? When minimum number is 1, that really indicate every department, because minimum 1 means that a department must participate in this manager's relationship at least 1. Okay, so that really can be translated into the total participation, means every department must participate in the managers, because minimum number of relationship instances is 1, right? So it means every department must participate in these managers at least one time. So that's why the participation will be total. The maximum number is also 1. So what does that mean? That means that a department can participate these managers only one time. Minimum is 1, maximum is 1. That means only one time. So the semantics here will be that a department will have only one employee manages it, because this department relate to one employee through these managers. So then the employee can be considered as the manager of the department. Okay. Then for the employee who works for department, okay. So on the employee side, the minimum is 1, maximum is 1. So that really means that an employee can participate at least one and only one time for this works for. The minimum 1 means that employee participate works for at least once, and the maximum once means that maximum once. So minimum, if minimum and maximum both are 1, that's really indicate an employee must participate in this works for relationship and only participate in one time. Okay, so that means an employee can relate to only one department, because an employee has only one relationship instance. He or she can participate and must participate. So that's why employee works for department means that employee works for only one department. On the department side, the minimum 1 indicate every department must participate in this works for, because that's a minimum number of relationship instance a department has to participate in this works for. And the 1 means at least 1. So means every department must participate the works for. Okay, then N, this capital N also means multiple. So this N means that maximum number of works for relationship instance a department can participate will be multiple. So what's the semantics of this multiple? That really means that department participate works for multiple times, because multiple relationship instance. So that means that a department can have multiple employees working for it. Okay, so this kind of notation, really minimum maximum notation, if you are familiar with UML, so this minimum maximum notation may are similar. Unfortunately, the only differences is that I think the location of those minimum maximum pair is different from UML. I think UML notation will basically put this 0, 1 to the department side and put 1, 1, 1 to the employee side. So that's why you have to be careful what's the meaning here. You have to make sure you put the location in the right position. So this shows kind of a alternative minimum maximum notation for the relationship constraints. So here I want to emphasize that when you design your database, you can either use the minimum maximum notation or combination of the participation constraint and coordinate ratios. So there are only 2 methods, or only 2 ways, not options, for you to representing the relationship constraints, either using minimum maximum notation, so that's enough, or use coordinate ratios plus participation constraint. So coordinate ratio and participation constraint together can also use to describe relationship constraints. Then regarding which notation you like, I think it's totally up to preferences. So I think both are pretty easy to understand, and also we can easily translate one option to the other. So either minimum maximum to the coordinate ratios and participation constraints, or from coordinate ratio and participation constraints, we can simply translate them into minimum maximum, because minimum indicate what? Indicate participation constraint. Maximum indicate the coordinate ratios. So that's basically what it means. So I think I want to okay, so this is the last one. So this basically, let me make it bigger. So this is actually a design, ER design using minimum maximum notation. Okay, instead of using coordinate ratios and participation constraints. So this is using minimum maximum notation. I think we do have a, yeah, this is using the coordinate ratios and participation constraints, like double line, single line, participation constraints. So this basically the two identical design. The only difference is that they use different notations for relationship constraints. So when you design, you just pick one of those notation, either constraints or maximum notation. Okay. Okay. Questions? Any questions? Okay, so I think it's the best learning probably coming from the practice of design. Okay, so I think the remaining is pretty much, I think you have to this kind of design principles. So faithfulness means that you have to fully follow the data description faithfully when you design ER diagram. Avoid redundancy means that you have to have, during your design process, you have to identify the redundant attributes and remove them. And simplistic counts. So basically means that we only model the relationship type as needed, solely based on the data description. If the data description does not inform any relationship type for between the two entity types, then you do not need to model them. Okay. Then choose the right relationship. So I think that also means that last one, pick the right kind of element. So I think here I want you to let's start work on kind of sample database. So let me bring my things so that we can learn together how to design the ER diagram. Okay, so let's do the, where's my real estate? Okay. So this is kind of a real estate database. So assume that we need to design, sorry, I probably have to restart. Yeah, it's showing my network connection is not stable now. Okay, so this is a database description that given this database description, we need to design a ER diagram for it. Okay, so let's start reading each bullet. So I'm going to show you how to identify entity types and how to inform or identify the relationship type. So that's the most important thing. So once you identify entity types, and then relationship types, I think at least the structure of your ER model is pretty clear. Then they're just kind of details you have to put into the design, like attributes, relationship constraint, and so on. So this, we want to design an ER schema for a real estate form that lists property for sale. So the following describe this organization. The form has a number of sales offices in several states. Attributes, so this gives you kind of a hint. Attributes for sales office include office number, location. Office number is distinct for each office. So at least based on the first bullet, we can tell that the sales office should be the modeled as the entity type. Why? Because it has several attributes. Okay. So then I think I want to emphasize that the form had several sales offices in several states. So since we designed this database for a specific real estate form, so that's why we don't have entity type called form. So recall that in our lectures, we kind of design a database for company. We don't have a company entity type. So that's basically the I want you to be aware of that. When we design a database for a specific company or specific form, then we will not have an entity type like a form or company. If, for example, we want to design an organization or maybe, I don't know, a cluster of companies, then we may have an entity type as company, okay? And also, office number is distinct for each office. So that really gives us the idea what attribute can be serving as a primary key for the sales office. Okay. Then each sales office is assigned one or more employees. So this assigned one or more employees actually, can I do the? It actually shows that's maybe the relationship. So if we have sales office as entity type, if I have employees as entity type, then this sentence really shows a relationship between the sales office and employees. So you see the attributes for the employees. So once again, we can tell that we're going to model the employees as excuse me, entity type because it has several attributes, and also an employee must be assigned to only one sales office. I think this may be used later when we decide the constraint for the relationship type. Okay. Then for each sales office, there's always one employee assigned to manage that office. So this kind of shows that a relationship type between an office and an employee. That employee will be the manager. Okay. So if we have employee in the sales office, then this will be one relationship between the sales office and the employee to identify the manager of the sales office. It's very similar to our company database. We do have a managers relationship between employee and the department. Okay. So you also need to be aware that this sentence describes another relationship between the employee and sales office. That basically means that a sales office is assigned one or more employees. It's more like a works for relationship. So the form lists property for sales, attributes of property. So once again, that indicates we need to have a property as model the property as an entity type, as it has several attributes. Okay. So some kind of unique that really indicate what? Indicate the potential primary key for the property. So each unit of property must be listed with one and only one sales office. A sales office may have any number of properties listed or may not have properties listed. So we have properties, we have a sales office. I think this kind of a bullet mainly used to describe a relationship First, each unit of property must be listed within one or only one sales office. So we have sales office entity tab, we have property entity tab, this representing the relationship between the two. Then a sales office may have any number of properties listed or may not have properties listed. I think the second sentence pretty much can help us to define the constraints of the relationship between the sales office and the property, okay? Then each unit of property has one or more owners. So attributes for the owners. So once again, owners should be modeled as an entity tab, okay, based on the data description. Then we have owner entity tab, we have property entity tab. Then this sentence really shows us the relationship type between the owners and property. So like owner ID is unique for each owner. That's usually indicate owner ID can be the primary key of the owner entity tab. An owner may own one or more units of property. So this really kind of help us to define the constraints of the relationship between the owner and property. Okay. Attribute of the relationship between property and owner is percent owned. Okay, so that really indicate for the relationship between the property and the owner, there is an attribute to describe that relationship type that indicate what percentage of the ownership that an owner have on a specific property. Okay, if a property is sold, the database should record the sales price and the date. So this, I think this can be means that we also need to record the sales transaction between the property and the owner, right? And then we need to record the sale price and the date. Okay, so this basically based on the data description, I think we have at least identified 4 entity tabs. Okay, so let me bring my visual. So I need to make it a little bit smaller, yeah. So hard to move it. Okay. Then let me bring my visual so that I'm able to draw much easily for the yard diagram. So this is pretty much the initial entity tab we identified. Okay, so basically in our design, I think we have to follow the step-by-step approach. The first step, we need to first identify the entity tabs. That's the first step. Once we identify the entity tabs, then we can go to the data description to inform the relationship tab among those entity tabs. Okay, so we identify 4 entity tabs: sales office, employee, property, and owner. I think that's the 4. Okay, questions? Okay, so then let's see the relationship tab. So between the, let's say the first line we marked. So each sales office is assigned 1 or more employees. So that means that we have between the sales office and the employee, we should identify a relationship tab. Can I do a shape? Maybe let me make it larger. Come on, where's my relationship? Where's my, okay. Maybe I need to search diamond. That should be the, yeah. So I put diamond here. Okay, it is too big. Okay, I think now we do not need diamond. So for this diamond, maybe I just use has. So for the relationship tab, you can give any name you want, but by tradition, you're going to use the verb to represent a relationship tab name. You use kind of a noun to represent the anti-tab name. And also another tradition that we use all uppercase words to representing the anti-tab name and relationship tab name. Then we use capitalized word to represent attributes. So I think this kind of, if you follow the tradition when you design a database, at least people believe that you have some kind of a formal training in the design. So it's nice to follow those kind of tradition. Okay. Connector. So no. Why it's not allow me to do the I don't like that one. So let me, I don't know why it's not showing here. I just want to as simple as possible. Just want to a simple straight line. Come on. Let me see. Okay, but I got it. So I put the line connecting has with employee. Okay, so this is kind of one relationship tab. Then unfortunately, so the second one, we underlined. There's always one employee assigned to manage that. I think sales office. So that's why I think we can also use another relationship tab to represent the relationship between an sales office and an employee. So that indicates the employee manages that sales office. Okay. For example, I use is managed by. Okay, so that's another relationship between the sales office and an employee. Okay, so this is actually showing that I think in the last example, company database, we also see that between two entity tabs, we may have more than one relationship tab. Okay, so here between sales office and employee, we have kind of two entity tabs. Okay, two relationship tabs. Okay, next one. each unit, let me see. Each unit property must be listed with one and only one sales office. So that's usually indicate the between the sales office and the property, we have kind of one relationship to capture like which sales office list the property. Okay, usually list for sale. Okay. Okay. Then what else? So then each unit of property has one or more owners. So that means between the property and owner, we should have kind of a relationship to capture who is the owner of a property. Okay, so for example, I use owned by. So property is owned by an owner. Okay, so this is kind of how I kind of draft the design. So the first step, identify the entity types, then trying to infer the relationship types based on the data description. So we have to truly forcefully design the database and follow the data description to design the YAR model, YAR diagram. Okay, so that's very important. So we never add any entity types or relationship types that are not mentioned in the data description. Okay, so let's see. The last one is that if a property is sold, then the database should record the sales price and the date. So I think this can be okay. This can be represented by a relationship between the property and the sales office. So the office sold the property list, or we can directly put those sales date and price to the property. So there's kind of some kind of a room that we can consider how we want to design. Okay, we may start with one option, then we see if this we can compare if one option is better than another. So I think finally we want to make sure the design is the simplicity counts, and also we capture all the requirements that user need in the design. Okay, so that's kind of the first draft. I think what else we're missing here? Let me double check. So an employee will manage only, okay, property. Okay, I think we have one kind of percent. So owner ID is unique for each owner and may own. So an attribute of the relationship between the property and the owner is percent owned. So that's indicate we have to have an attribute to represent the percent. So this attribute, the best way will be the relationship attributes. For attributes, we always use the capitalized noun word. So okay, so this percent basically means what? Means that if, for example, it's record a percent for each relationship instance, a relationship instance for this owned by we relate one owner with a one property. So put the percent as the owner owned by relationship type really provides very convenient way for us to record percent for every owner of a property. For example, if an owner owns multiple different property, maybe co-owned multiple properties, then this percent will be assigned to each relationship instance. So that percent will be describe each individual property that owner owns. Okay, so that's very flexible. So I want you to understand that this relationship attributes, this attribute will be append to each relationship instance. Okay, so in this case, it's able to capture all percent for each property by a specific owner. Okay, so I think we kind of discussed pretty much quite a few concepts in today's lessons, and also I show you the kind of the first draft of this database. And in the next class, we're going to refine the design by supplying the constraints for the relationship type. And also if we can tell that if there's anything missing in the first draft, then we can add it to this draft. So that's pretty much for today. So for today's lessons, I think you need to really understand the constraint, coordinate ratios, participation constraints, and minimum maximum notation. And also I plan to give you the second assignment so that you're able to start to work on the draft of your design. So on Thursday, we're going to finalize this design. If we have time, we're going to work on another example. In class exercise, I simply want to show you how to design the ER diagram based on the data description so that you feel, I hope that you feel more comfortable design your own ER diagram in the assignment. So any questions? So if you do not have any questions, then we are done for today. Thank you.